Okay, hi, I'm Bruce Gain. I'm with a company called, an analyst firm called REVCOM. We are based in the U.S., in Las Vegas. I'm physically based in France. I'm half French, believe it or not, despite my accent.
No.
Est-ce que des Français ici? No?
No.
Cool. Hey, so we've been looking at doing a lot of testing. That's what we do with REVCOM mainly. And what I've been seeing a lot is with the extending observability for our benchmarking test results of software performance, looking at different ways to do that, and for observability as well, in my case. And we found that eBPF is an excellent way to do that. Everybody here knows how eBPF functions, the basic functionality of it, I'm going to assume, right? Okay. So in my case, we're looking at it more of the observability aspects of it. And as we progressed, we found that more recently, in spite of all the great work out there, eBPF is still work in progress to extend everywhere, particularly for different software configurations. It's tied to the Linux kernel. I've been using Linux for 25 years. That's fine with me, but unfortunately, a lot of people have not seen the light and are still using different other types of operating systems and CPU. Well, the CPU configurations are excellent. For example, a RISC type of device and ARM. But the operating system of, for example, Windows, they just recently made it so that eBPF could extend to Windows servers, for example, and that took a while, and it's still in progress. That was announced at KubeCon. Look, Google it. They claim it works. I haven't tested it yet. So what we're doing now is looking at different CPU and processor configurations. And again, it originally, given its adherence to the Linux kernel, eBPF has not yet extended, or is just extending now, to ARM processors and specifically to Mac M3 processors. That is working okay. My demo is not great, but I got it started. And before I do look at that, and I'll let Liang take over for that. It's now extending or beginning to extend to RISC or RISC-V specifically processors, and that is, I would argue that's a very necessary part of eBPF's functionality, because I really there's a lot of evidence out there that RISC will serve as a viable option and replacement in many cases for the classic CPU x86 types of processors and ARM processors as well. So that is who here is familiar with RISC? RISC-V, okay, cool. Yeah, there's a great article in Wired magazine on it. It's given a great overview for those like myself like a year ago. I did not quite get that. And so going to my part of the this demo is that ARM 64 processors, is it really ready for prime time? Kind of, they say it is. I've spoken with the good folks at for example, Grafana or Cilium, the open source project. There's Bela. They say it is, but I would argue it still remains a bit finicky for those types of configurations, and or for running on ARM, excuse me. And so I did a quick hit demo just to test it on my Mac, and it appears, it took a while, but it appears to be functioning at least in part. And I'll show you. And this is just, there you go. Supposedly I had to put it in a VM container and it was running. Now it looks like that's what I'm supposed to be getting, and it's still running and continuing to run. So I got the eBPF extending to my M3 processor, but this is very hello world, but this took a while, and I'm still not convinced that it's working as 100% like it should, but that's where I am with that. So let me give it now to the RISC, the good stuff, the RISC stuff, and I'll give it to
Okay.
Ning.
Yeah.
Excuse me, I didn't introduce you, Ning. So
it's
I'll
okay. I'm going to do a quick introduction. I had to change the laptop. We should merge it. So probably I just quickly run through that a very quick introduction. So just now introduce the BF. I run the DeepComputing. I'm founder of it, and then I'm a software guy. I'm VM guy. So if you know about eBPF, then you know it's just a VM. And I'm a software guy. Now I run a hardware company where I make laptops, all the RISC-V laptops. This side is the most expensive one, $5,000. And that one is cheaper and cheaper. So, and by the time I make 2 generations, I don't want to make my laptop anymore. I start focus on making motherboard for framework. So there's framework booth and RISC-V booth. And just along in the AW building. So come along and see all the imaginations. So the reason we make all the RISC-V into modulars is because openness. It's a kind of open hardware together with open source, the same ideologies. So it's very good for European style, the culture, DIY, like IKEA, and repairable. So, and you can see this is the first generation of our motherboard. And then this is the second generation of our motherboard. And it's a chiplet version, first RISC-V chiplet version of AI. And before the DDR crisis, money actually is not very expensive, €300 or something. Now it's probably gone up to 500 because of DDR. So, and now the third generation, so we will make, this year is the most powerful one. It probably equivalent to ARM's high end now, except the nanometers. So, and do come around and see all this cool stuff. Okay, back to the eBPF or the RISC-V. So you can see, and in Central and in this kernel, it does already has support the eBPF. So it is the, I think is in this kernel going to drop the 32-bit support anyway. And then it's only left RISC-V 64-bit, and you can see all this G compiler and all this is very simple things. This is the current status of the RISC-V of the eBPF, and then what actually the performance improvement. I think the maintainer do some of the instructions and manipulations to do the swap and all with all the specify the RISC-V instruction to increase the eBPF VM performance, and some of those compressed instruction as well. So that's part of it. But in fact, what just now says that so actually eBPF can do a lot of things. Most 90 is on the security side. On the Linux module to control all those access. So and you can see that in the old way for eBPF, and it's just a VM. In the old way, software guys usually can ask the hardware guy to support its instructions. So eBPF, the core of it is just a VM, and with their own bytecode and all the definitions. And because RISC-V is such a open ISA, and now I can give people of whoever interested in BPF can think about that. We no longer need the VM in the kernel, and you no longer need the bytecode. And people can think about it, ask the RISC-V processor to support so-called eBPF or bytecode extension. So basically, the RISC-V instruction can implement whatever the bytecode is. then you don't need the JIT compiler anymore. So that will tell you the flexibility between, even within RISC, ARM, or RISC-V. ARM, you need to ask them for permission to do anything. But RISC-V is not. If you find a feature, you raise a hand, you go to RISC-V International, say, I'm going to do this spec. Whoever making the CPU, they're interested in implement the spec. For example, you say, this is a eBPF spec. Can you help me to implement all these instructions? And then I will get it run on the Linux kernel, and straight away. And the best thing, even a university, you can make BPF VM machine in RISC-V instructions, and then put it in the FPGA. And then you have a standard RISC-V SoC, and then when they don't recognize that's the instruction, they get bunched to your FPGA. So that is the flexibility. I tell you guys, you can put more imaginations around that. In the old days, you can't. You can't ask Intel to do anything. All you can do is stuck with it. But now, RISC-V, you can use all your imagination, do whatever you like, and make the best out of it. So that's our RISC-V laptop runs eBPF and logging what people do stuff. And I'm sure, now it's software-based VM. I guess you can think about making the hardware-based VM. And just like, how many years ago? 20, 30 years ago, when Java come along, we do have a CPU runs Java bytecode straight away. And also, if you guys still have Nokia feature phone, the old one, and that CPU runs the bytecode directly. And I was running the feature phone Java platform at the time for Nokia. So this is the imagination for RISC-V. Thank you, Bruce.
Fantastic. Thanks.
Any questions?
Actually, I just wanted to conclude that.
Oh, sorry.
Yes, that's right. As Unique just said as well, the ARM. We're going to run it. We'll get there eventually, of course, but we're still struggling, with the benchmarks we do. Specifically, we're looking at. I use Nix. We use Nix OS and Nix to run our benchmarks, for the reproducibility of that. And I really, eventually, we're going to use eBPF for that, but right now, there's still, for the ARM processors specifically, we still need to have it in the VM, with the kernel. So I'm sure it's possible. I've been told it's possible, but I haven't seen that yet to run it directly on the ARM processor yet. Whereas, as Yuning just showed and articulated, we can do that. We can run that now on RISC, and that's mainly thanks to the open source aspect of it, I would argue, as he articulated. So that's it. Any questions?
I'm curious what your experience is with respect to writing BPF code where the BPF binary is supposed to be portable between x86, ARM, RISC-V. So what support is there for making BTF work across platforms, or assuring helper availability across platforms, anything of that kind?
That's what I'm looking for, but I'm trying to look at Nix. I'm looking at Nix right now and using a Nix packet, or looking at that for eBPF, but I still haven't found that packet I want, or to be able to do that directly without going the VM route for ARM processors. I'll let Yunig answer the rest of that question if you like.
I think.
Oh.
About exercise. Thank you very much.
Maybe I should put the question a little bit differently. So my own experience with writing BPF code is that while the BPF VM is sort of well defined
Okay, and basically your question in sum is that how's the portability works across different hardware architectures. And that's one of the principle original for BPF is saying that I need a VM, I need a standardized a bytecode, so that the bytecode can run on any of the architecture. And then when it runs, it JIT to the simple JIT. I can't remember the JIT name, is it JIT Bugger or whatever. And it JIT to the corresponding architectures. So the JIT is very simple because and eBPF, the app code is very simple. It's very similar to back in the old day, the Java applet and or mobile phones. We call it Midnet. Very simple, and that's the purpose of it. When you have a VM, you have a JIT. That means your eBPF application is portable. And by the time the reason why have a JIT, and the JIT needs maintained, and that's part of the painful things. And especially like ARM still evolving from ARM V8, V9, V10, and V, and all those things. And I would think that in terms of that, I would think RISC-V probably more appropriate, because you can just very simple. This is eBPF customized instruction according to spec. They never change according to the main CPU spec. It doesn't really care about your main CPU instruction anymore. That is why I think if you have a hardware VM, the hardware actually coprocessor deal with all the eBPF instructions. It's far easier than you maintain a VM and JIT and make sure that they're all correctly implemented. Back in the old day, when we do a VM, we had to run 100,000 test cases to verify the VM is correct. But now, probably, I don't think eBPF more than 1,000 cases, right? So you have no idea whether the VM works or not correctly across different architectures. 20 years ago, when I started doing Java VM porting, I port PowerPC, MIPS, ARM-V, at the time, V1, V2, ARM11, and then not even core. That we had to make sure the VM is actually properly tested. But I don't think eBPF is there yet. So portability is a thing, maintenance another thing. But anyway, now with AI, so probably the AI can rewrite the VM every night. That's all.
Okay.
Thank you.
Okay. You're free to go. Thank you.
Thank you.